There are 6 different shapes of graph that you might come across in GCSE science. The first ones are straight lines like this. There is one that I haven't drawn on here. There's another straight line, just looks like that, horizontal. That's fairly straightforward, hopefully. That's nothing changing. Students are generally happy with that one, so I've not gone through and explained that one in this section. But these are the 6 other ones here. These are all examples of as x increases, y increases. Okay, so these are all examples of that. So we've got x, remember, is that the along axis there, and y is the up axis there. Okay, so these are all as x increases, y increases. Now, the fact that as x increases, y increases, okay, they all slope upwards, and if you were to write it goes up, then you're not going to get any marks for that at all. However, they do all go up, and if I imagine that there's a little person here, and that little person is at the origin of each of these graphs and is walking along, following that, walking along them, in every case they're going to go up from there up to here. They all finish at approximately the same height, I think. So as x increases, y increases, and that would be the start of an explanation for any graph that goes up. If it was a graph going down, I would simply say as x increases, y decreases. So I'd go that way. Okay, in this case, the little person's walking down the hill. Okay, in each case, they end up down here. Now, that's only part of it. So as x increases, y increases or decreases, tells you if it's a hill, you're going uphill or downhill. Now what happens here is the steepness or the rate of each of these curves. Now if we look at this graph here, the steepness, although you're going up, the steepness is not changing at all. It's the same steepness all the way. And whenever you see a straight line, the word I'd like you to use is constant. So this line here goes up as x increases, y increases, with a constant steepness or rate. Okay, so we think steepness, but the word we use in science is rate. So with a constant steepness or rate. You might also use gradient in maths. So as x increases, y increases with a constant steepness or rate. This one here is a little trickier. As x increases, y, what's happening to the steepness here? Y increases with a, what's happening to the steepness? Well, it starts off really steep. It's hard to, I wouldn't like to cycle up this hill. You start there, it's really steep. And then it gets less steep. So the steepness must be dropping. So that is a decreasing steepness or rate. Which means this one here, naturally is going to be constant, decreasing, this will be increasing. And let's just check, does that make sense? So increasing rate, increasing steepness, starts here, it's not very steep. By the time they get up here, that's really steep, it's like a half pipe, and yeah, they can't get up that at all. So that's going to be increasing steepness. So that's how a perfect 2-mark explanation of any graph. And it works the same for the ones down here. So here, as x increases, y decreases with a constant steepness or rate. Here, as x increases, y decreases with a decreasing steepness or rate. It's getting less steep as they move along here, as x moves that direction. And here, the last one, as x increases, y decreases with an increasing steepness or rate. It's getting more steep as they go. We're going to use that description. The great thing with with that way of explaining the shape of a graph is that it covers biology, chemistry and physics, and you can take any graph you like, absolutely any graph, and even if it's horribly complicated, you can split it up into bits. So that's a horribly complicated graph for certain, but I could split it into that bit, I could split into that bit, my diagram's awful, sorry, that bit, and I could talk about A, then I could talk about B, and C, and D, and E, and I could talk about each of those bits of the graph separately. That's called segmenting the graph. Now that's a really complicated one to do. It's unlikely you'll ever have to do anything quite that tricky. This graph here and this graph here come up a lot though in rates of reaction, rates of photosynthesis, yeah, things like that. Okay.